Welcome to this set of instructional videotapes on the autostock scratch removal system. These tapes will show you how to set up, operate, and maintain the system. Before operation of any of the autostock equipment, please familiarize yourself with the operation manual. Pay special attention to the sections on operational safety. The autostock scratch removal system includes the following components: a polishing bucket, a fining bucket, the polisher, the finer, a water lubrication tank, the GFI system, machine power cords, and 3 boxes. One box contains tools and materials for machine adjustments and maintenance. An adjustment gauge is included to help you adjust the shroud and mark the scratch location on the glass. The second box contains polishing compound and shroud seals. The last box contains fining compound, fining pads, fining discs, and shroud seals. When operating, both buckets contain the polishing or fining slurry and a pump that creates the vacuum holding the machine on the glass. The pump also circulates the slurry throughout the system. The finer is used to prepare deeper scratches. The polisher is used to polish out small scratches and to restore the glass luster to fined glass. The power for the system goes through the ground fault interrupter or GFI system and an outlet box that will protect you in case of an electrical short. The system comes with 2 power cords that go between the machines and the GFI. The water lubrication tank holds water that helps lubricate the glass when the machine is operating. Next, we'll show you how to set up your buckets and connect the tubing. The system comes with 2 buckets which are identical except for the number of hoses. On top of the buckets, a vacuum gauge tells you how much vacuum the machine develops as it sits on the glass. The vacuum gauge indicates how securely the machine is held on the glass. The higher the vacuum, the stronger the grip of the machine. With a lower vacuum, the machine will be easier to move, but will not be held onto the glass as securely. On top of both buckets is a vacuum adjustment valve. This valve adjusts the amount of vacuum the pump generates. The valve can be adjusted at any time, but the gauge only reads the vacuum when the machine is secure on the glass. Both buckets also have a vacuum vent. Inside each bucket are hoses and a pump which creates the vacuum and circulates the polishing or fining slurry. Each bucket also holds a small package which contains the aspirator assembly. You may also see some flecks on the bottom of the bucket. These flecks are residue from the testing process that each bucket goes through before leaving the factory. The aspirator assembly is an important component of the bucket system. Be careful as you unwrap it. Once unpacked, you will notice the aspirator has a threaded end and a vacuum pickup tube threaded into it. The threaded end will be placed on the pump and will create the vacuum. To install the aspirator assembly, put the machine threads into the pump housing and rotate clockwise, being careful not to cross-thread it. Tighten it hand-tight. The orientation of the vacuum pickup tube is very important. When placing the aspirator assembly on the pump, the vacuum pickup tube must be positioned so that it is sticking straight up when the pump is on its side. The machine comes with 2 similar hoses, the dual tube for the finer and the tri-tube used with the polisher. When connecting a hose to the bucket, begin with a hose end that has a section cut out. Put it through the hole on the top of the bucket cover. Install the Y fitting into the cut-out section of the 2 hoses. When completed, the fitting should look like this. Make sure that the hose is placed over all 3 of the barbed fittings. Finally, place the shorter of the 2 hoses on the vacuum pickup tube located on the aspirator assembly. When you place the pump into the bucket, make sure that the pump is on its side, with the pump's exhaust port on the bottom and the vacuum pickup tube pointing up. When you replace the cover, let it rest naturally on the bucket. The hoses have a tendency to coil inside the bucket. Snap the bucket lid in one or two places. The autostock polisher and finer are the two patented machines designed to remove scratches easily with very little distortion. We begin with the polisher. The polisher is used to remove lighter scratches. Most light scratches can be removed using the polisher alone. The polisher comes with two different polishing wheels or pads. One is the domed pad used for removing single-line type damages. The other is the flat pad used for general cleaning, removing deposit-type damages, and also for removing fining marks. The black funnel on the end of the polisher is the shroud. The shroud has two major functions. One is to keep the polishing pad parallel with the glass. The other is to contain the slurry during polishing. This is the vacuum fitting, where the white hose will be connected. Excess polishing slurry from the shroud and pad goes through this fitting back to the bucket. Please note the black O-ring on the quick connect. Special care is required to lubricate it with a water-based lubricant each time a hose is connected. There are two water lubrication jets mounted on opposite sides of the polishing shroud. These jets provide a stream of water which allows the machine to move easily across the glass. A shroud collar creates an airtight seal between the quill shaft and the shroud, holding the shroud stationary. This is the input fitting, where the black hose will be connected. This fitting is connected to a precision-ground stainless steel extended input tube. When handling it, care must be used so the tube does not bend. Slurry enters the input fitting before traveling down the length of the machine to the pad. This is the retraction handle. During normal polishing, the handle should either be completely retracted or completely released. Retracting or pulling in the handle will pull the pad off the glass. Releasing the handle allows the pad to make contact with the glass. Do not hold the handle partly in under normal circumstances. The retraction handle is very responsive to any pressure, and holding the handle even lightly will change the amount of polishing done on a particular area. On top of the handle is a fine adjustment screw that adjusts the amount of pressure that the pad puts on the glass. The fine adjustment screw does not move the pad, but rather increases the pressure a spring puts on the pad. This change in pressure is reflected in the amperage gauge when the machine is running. We gauge how effectively the machine is removing the scratch by how many amps it draws. Turning the fine adjustment screw clockwise increases the amount of pressure the spring places on the pad and will increase the amperage. Turning the screw counterclockwise lessens the amount of pressure on the pad and reduces the amperage. Higher amperage means faster polishing. Lower amperage means slower polishing. The quill shaft connects the top and bottom of the machine. It also serves as a handle for the machine during operation. It contains bearing and housing assemblies for the machine. The motors in the polisher and the finer are identical. They are 1 3/4 horse motors that spin at 24,000 RPM. The motor is attached to a toothed drive belt system that slows the drive motor down by a ratio of 4:1. This means that the polishing pad is rotating at nearly 6,000 RPM. Make sure the machine is held securely when switching it on because torque twist will develop. Here are the two polishing pads that are used with the system. First is the flat or cup-shaped pad. It is used for removing fining marks from the glass after fining. It is also used for removing deposit damage or wide area damage such as hard water stains, lime deposits, or aluminum deposits. Notice the grooves that cut into the face of the pad. These grooves will wear down with use and should be periodically reopened using a razor blade. Next is the domed pad. It is used primarily for removing lighter damage, such as inline scratches. This pad also has 3 grooves cut into the face, which need periodic maintenance to maintain a constant size. These pads will also flatten through use. We will talk more about pad maintenance later. The amp meter is located on the side of the polisher. The polisher will draw 5 to 6 amps with no load being drawn. During normal polishing operation, the load will be between 7 and 11 amps, depending on the type of pad and the kind of damage you're working on. We will discuss amperage settings in more detail later in the program. This is the power switch. The switch will sense too much heat and will turn off the machine if you attempt to remove too much glass too quickly. Once the machine has been automatically turned off, manually turn the switch off and wait 5 to 10 minutes for the switch to reset. The vacuum release valve is located on the shroud. It releases the vacuum and allows the shroud to drain. When removing the polisher or finer, pull this valve to release the machine from the glass. This is the polishing chuck on the polisher. It is where the domed or the flat pad will be placed. Next, we will discuss the finer. The finer is used to prepare deeper scratches for removal before using the polisher. The autostock system works quickly and is very effective at removing scratches without creating great amounts of distortion. This is because the finer grinds away a wider portion of the glass more quickly than the polisher can. Once the finer has been used to grind away the scratch and surrounding glass, the polisher restores the glass luster. The finer uses many of the same components, such as the motor housing, and the retraction handle. One difference between the polisher and the finer is the presence of an amp gauge on the polisher. The finer does not need a gauge because the load on it is very light. The finer also has no extended input fitting for the slurry. The fining solution enters and exits through the shroud. The black input fitting is located on the opposite side of the white vacuum fitting. Additionally, there are no water lubrication jets. This is the fining disc. These are the fining pads. They are placed on the bottom of the orbiter assembly and do the actual fining. This is a fining pad. It has a mylar side and a self-adhesive side. To apply, make sure the orbiter face is clean by using isopropyl alcohol to clean and prepare the surface for bonding. To place it, remove the white paper and center it over the orbiter assembly. The fining disc is then applied using the self-adhesive side of the disc. Make sure it is centered and press it into the clear mylar face of the fining pad. Replace the disc before every fining job because the discs wear quickly. To remove the disc, place a fingernail in the notch and pull it away from the fining pad. The fining pad should be removed and replaced whenever the mylar face becomes damaged. This is the orbiter assembly, fining pad, and fining disc properly assembled on the finer. Note the large half-circle balance used to offset the orbiter assembly. The maintenance kit contains a 6-inch T-handled Allen wrench, a drive shaft seal, a small bag that contains short and long plastic rivets for the shroud feet, one each of the white and black quick connect fitting for the polisher and finer, a container of water-based lubricant that is used to lubricate O-rings, an extra drive belt that can be used for either the polisher or the finer, an adjustment gauge that is used to mark the location of the scratch and adjust the pad height, and a shaft seal. This is the Finer System Expendable Materials Kit. It contains 5 bags of fining compound, 3 shroud seals, 2 fining pads, and 50 fining discs. This is the Polisher System Expendable Materials Kit. It comes with 5 bags of polishing compound, 3 shroud seals, 1 domed pad, and 1 flat pad. The autostock scratch removal system has 2 different assemblies: the finer assembly and the polisher assembly. Each assembly consists of a slurry bucket and either the finer or polisher machine. Both the finer and the polisher use a slurry bucket which holds an electric pump that creates a vacuum. The pump is connected to the polisher or finer by 2 hoses. The first hose is the supply hose, which draws the slurry up to the machine where the slurry circulates through the polisher or finer. The second hose is the vacuum hose. It pulls the slurry from the machine back into the bucket. When the polisher or finer is placed on the glass and a vacuum is established, a continuous flow of slurry runs from the bucket to the machine and back to the bucket. As the slurry circulates through the system, the electric motor of the polisher or finer may be turned on. The retraction handle allows the polishing pad or fining disc to be pulled from or extended onto the glass. The pad or disc holds the slurry momentarily, then forces it against the glass. The machine is then moved across the scratch by hand. When the work has been completed, the motor on the polisher or finer is turned off, and the slurry drains from the shroud back into the container. The machine may then be removed from the glass. You will need a circuit with a minimum of 20 amp service. The polisher can draw up to 14 amps, and the pump in the bucket will draw an additional 3 to 4 amps. Do not use extension cords that are longer than 50 feet or that are smaller than 14 gauge. The GFI must be used with both the polisher and finer buckets. Failure to use the GFI may result in electrical shock to the operator. If extension cords are used, they should be plugged into the GFI outlet and not the wall plug. See the warning on the GFI system for more information. The equipment can be used with a portable generator, but make sure the generator is capable of producing 2400 watts of power continuous duty at 110 volts. The first step is to adjust the preload tension on the polisher or the finer. The tension needs to be adjusted before you adjust the pad height and before you begin any fining or polishing operations. To adjust the preload tension, back the adjustment screw out until the flat washer contacts the metal dowel pin. Then turn the screw clockwise 3 full turns. This gives you a good starting point for future adjustments on the finer or polisher. Remember, this must be done before you adjust the pad. Without the proper preload tension on the spring, you may make an incorrect adjustment. When adjusting the preload tension, the pad itself will not move. The amount of force on the spring increases or decreases. To put the polishing pad on the polisher, use the shroud adjustment gauge, an Allen wrench, and the polishing wheel. Before beginning, make sure that the fine adjustment screw is correctly adjusted. Begin by turning the machine upside down to remove the quill shaft pad. Place the Allen wrench into the hex head screw and loosen the shroud collar. Lower the shroud by twisting it down. Inspect the pad and polishing chuck to make sure they are clean and dry. Place the pad on the threaded section of the drive shaft and turn it counterclockwise. Then place your hand under the chuck and tighten the pad so that it is moderately tight. The shroud should be adjusted so that the correct amount of pad extends below the shroud. To do this, place the shroud adjustment gauge so it rests on the white shroud feet, not the shroud seal. Next, move the shroud so the pad touches the top of the cutout section of the gauge. Then replace the shroud collar. Do this by holding the shroud collar next to the tapered section of the shroud. Make sure that the groove in the shroud collar is lined up with the center of the machine. Then take the Allen wrench and tighten the hex head screw. After tightening, recheck the shroud's positioning with the adjustment gauge. The polisher is now ready for use. Now we will mix up the polishing slurry. With the bucket running, carefully lift off the top and set it to one side. The amount of bubbling you now see is normal. Take the bag of polishing compound and shake it down. Tear the bag at the notch. Slowly introduce the compound into the bucket so that it mixes properly. Mix a little at a time while the bucket is running. The mixing of the compound should take about 1 minute. Then check to make sure that all of the compound is in suspension. Do this by touching the bottom on the bucket and mixing the slurry with your hand. It is now ready to be used. Before connecting a machine to its bucket, test to see if the bucket's vacuum system is working to its capacity. Turn on the GFI system, crimp the hoses near the bucket, and turn the vacuum relief valve all the way in. The needle should hold steady at least 24 inches of mercury. After testing the bucket, lubricate the O-rings on both the quick connects and water lubrication jets using the water-based lubricant. Next, connect the white vacuum vacuum fitting on the shroud. Then, connect the black input fitting located on the top of the machine. Finally, connect the water lubrication jets. Before you put the machine on the glass, pull the handle in. Push the vacuum release valve in, and place the shroud against the glass and listen for the sound of slurry flowing into the shroud. Once there is sufficient slurry flow, adjust the vacuum to the proper level. This is generally between 7 and 10 inches of mercury. Start the water flow for lubrication and rotate the shroud so the white quick connect is at a 3 o'clock or a 9 o'clock position. Turn the machine on to begin the polishing process. Remember not to let the handle out until you have started moving the machine. To remove the machine from the glass, pull the retraction handle in, stop the motion of the machine, shut the motor off, turn the water lubrication jet off, and rotate the machine so that the white vacuum fitting is pointing down. Pull the vacuum valve out, allowing the slurry to drain out of the shroud. Then tilt the shroud back, keeping the bottom edge of the shroud touching the glass, and remove the machine. At this point, please stop the tape and practice putting the machine on and taking the machine off the glass. Once the polisher is on the glass, adjust the amperage and the vacuum settings. To adjust the vacuum, turn the vacuum valve clockwise to increase the vacuum, or counterclockwise to reduce the vacuum. Once the vacuum is set, turn the polisher on, start the polisher moving, release the handle, and observe the amperage reading. The polisher needs to be polishing the glass for the reading to be accurate. To increase the amperage, turn the fine adjustment screw clockwise. To decrease the amperage, turn the fine adjustment screw counterclockwise. Remember that the amp gauge will only read the amperage correctly when the polisher is under load, with the retraction handle out. When operating the polisher, the amp gauge needle will never be perfectly steady. It's normal for the needle to bounce 1 or 2 amps each way. Before continuing, please practice starting and stopping the polisher on the glass. The characteristics of a scratch that are important in scratch removal are depth, width, and uniformity. The depth of a scratch is critical because it will determine how the scratch will come out and what amount of distortion will be left. Our system is very effective in removing moderate scratches, leaving very little distortion. However, there will always be some distortion when you remove a scratch because you are removing some glass. The width is also important because a wider scratch is usually easier to inspect and to remove than a narrow one. The uniformity of the scratch is also important. Scratches that are not uniform are often difficult to remove. It is often thought that if a scratch can be felt with your fingernail, it cannot be taken out. However, our system can remove scratches that are deep enough to be felt with a fingernail. Personal experience is important when determining what can and cannot be removed with acceptable distortion. When inspecting a scratch, pull a fingernail across the glass. Try to inspect the scratch in several different areas. Judge the scratch based on how it compares to other sections of the same scratch. It is important not to confuse depth with width. Often a wide scratch will feel deeper than it actually is. Scratches are seldom a consistent depth or width, so it is important to check the entire length of the scratch to find the deepest part. A wide scratch is usually easier to remove using this system because there is more surface area for the finer and the polisher to operate to remove the scratch. It is usually helpful to find out what caused the scratch and what the scratch is on. Scratches are caused either accidentally or intentionally. It is also important to know the use of the glass. The use can be in one of two areas: visually critical or visually non-critical. Critical glass includes a driver's windshield or a bank teller's window. Non-critical glass includes a home window, office window, or mirror. Once you have determined how the scratch was made, and if the glass is visually critical, there is a general rule to follow. If the scratch is caused intentionally and located on critical glass, the scratch removal may leave distortion that will not be acceptable to the customer. Accidental damage usually can be taken out easily. Vandalism on non-critical glass can usually be taken out without unacceptable distortion. Damage can also be caused by deposits on the glass. These are grouped into four areas: aluminum deposits, lime deposits, hard water stains, and power washing chemicals. The autostock system will remove these stains and deposits easily. After inspecting the scratch, ask the customer about his or her expectation for the scratch or deposit removal. In the case of a deep scratch, if the customer is insistent upon having a perfectly clean piece of glass with no trace of the scratch or distortion, this may not be a good application. When using this system on deep scratches, there will be some slight distortion in the glass. If the scratch is light on visually non-critical glass, very little distortion will be apparent. Always find out what the customer expects. Often the removal process can be used to dramatically improve the scratch, but may still leave minor nicks in the scratch path. Sometimes a customer would rather have a few nicks than risk the possibility of distortion. When selling the scratch removal process, compare the cost of scratch removal to the cost of replacing the glass. These are examples of wide multiple line damages. They range from very light and easily removed with the polisher only to those scratches in the center that are deeper and will require fining. These types of scratches may be caused by rubs, multiple scrapes, or vandalism. This is an example of a single line scratch that is not straight. This was probably caused by vandals. Even though these are only single line scratches, the entire area will need to be fined and then polished to remove the graffiti. This is an example of rub damage. Sometimes when one sheet is moved across another sheet of glass, this type of damage will occur. This looks severe, but will easily come out using only the polisher. This is an example of deposit damage. It was made by an aluminum pop can rubbed on the glass. This damage looks quite severe, but can be easily removed using the autostock polisher. This is an example of a single-line inline scratch caused by a wiper blade with the rubber missing. It looks bad, but is not hard to remove using the polisher only. Distortion is caused by reducing the thickness of the glass in a localized area. The amount of visible distortion could have been lessened by removing more glass in a wider area. Also, if the polishing hadn't been as deep, the distortion would have been lessened. For deep scratches, use the finer first. The finer is able to remove a wide path of glass, spreading the distortion over a wide area, making it less noticeable. Once glass has been distorted, nothing can be done to remove the distortion. Attempts to lessen the distortion make it worse. That's why it is important to do regular inspections of the scratch as you work. This distortion was caused by running the domed pad in one spot for less than 30 seconds. Never leave the machine running in one spot with the pad on the glass. The first step in marking the scratch is to place place a line on the outside glass between the operator and the scratch. This line will be used to guide the machine along the scratch. Transfer that line to the opposite side of the glass. If you leave the marking on the scratch side, the polisher will remove the lines. Next, mark two end lines about an inch past the visible end of the scratch. Finally, place small locator lines perpendicular to the scratch and directly under the scratch's location. There are 4 basic machine movements used for damage removal. The inline movement is used with the domed pad. Use this movement to remove single line scratches. The oval and zigzag patterns are used to remove fining marks or remove wide area damage. The crosshatch pattern is used to remove the same amount of glass over a wide area of the glass. It is commonly used for deposit damage, aluminum can deposits, lime deposits, or hard water stains. When polishing, make sure that you start and stop the machine in a different place as you make each pass. You do not want any hard edges to be noticed when the polishing is finished. Make sure all your transitions are smooth. Do not start and stop in the same place each pass. Amperage settings are critical to machine operation. Having the correct amperage set means that you will reduce the total time needed to remove the scratch. For straight inline scratches, operate the polisher at 9 amps. When the amperage is reduced by 1 amp, the amount of time required to remove the scratch will double. For example, if a scratch takes 10 minutes to remove at 9 amps, it will take 20 minutes at 8 amps. However, don't run the polisher at over 11 amps for extended periods of time, because the motor will overheat and the safety switch will turn the machine off. Inspect polishing progress every 5 minutes. For higher amperage settings, check it more often. For light inline scratches, check your progress every 5 to 7 passes across the glass. To check progress, pull the retraction handle in, move the polisher to a different area of the glass, turn the machine off, release the handle, wipe the scratch completely dry, and inspect the progress you are making. Why test the polisher before operation? One reason is to decide if you will use the finer and polisher or just the polisher. To do a polisher test, install the domed pad on the polisher and mark the glass. Operate the polisher at 9 amps, with the vacuum set at 7 to 10 inches of mercury. Make 2 passes across the glass. Remove the polisher from the glass, wipe down the glass, and inspect the scratch for noticeable improvement. If there is noticeable improvement in the scratch, then you will be able to remove the scratch using the polisher only. If there has not been noticeable improvement, then the glass must be prepared with the finer. Another reason for a polisher test before fining is to verify whether or not the polisher will operate in that location and that there are no problems with the polisher itself. If there is a problem with the polisher or the location, do not fine the area. You will not be able to remove the fining marks from the glass. The finer will operate on sharper curves than the polisher, so make sure that a polisher test is done before fining. If no fining is necessary, then continue using the polisher to remove the scratch using the same motion used in the test. During machine operation, the pads become smooth. They must be deglazed every 5 minutes. Use a brass brush, not a steel brush. A steel brush will rust and put iron particles into the pad and cause damage. Use it to roughen up the pad surface. The polishing action is reduced when the pad is smooth. The pad on the left has been used, and you can see the domed section is flat and will need to be reshaped. Reshape it using a wood rasp to maintain the bevel of the pad. Go around the pad to reduce the shoulder height so the bevel will be the same as a new pad. The reshaped pad will become shorter. Another item to watch for is the depth of the 3 grooves in the top of the pad. These 3 grooves have to be deep enough for slurry to flow out of the pad. If the grooves are too small, there will not be enough slurry flowing through the pads. The pad will overheat and crack the glass. The grooves must be periodically reopened to the same size as a new pad. This can be done with a razor blade. These operations must be done on both the domed pad and the flat pad. If fining is necessary, make a one-pass fining test to make sure that the finer is operating correctly. This is an example of a correctly fined first pass. Each time you use the finer, you should put a new disc on the fining pad. When putting on a new disc, check to make sure that the mylar face is not damaged or worn. If the mylar face is damaged, then replace the fining pad. Before beginning fining, adjust the preload adjustment screw in the same way as the polisher. Back the screw all the way out until the flat washer touches the metal dowel pin, and then turn it 3 full turns clockwise. The finer shroud is adjusted differently than the polisher. You will use a straight edge, not a gauge. Place the straight edge on 2 shroud feet across from each other. The fining pad should be bisected by the straight edge. In other words, the top of the feet should be level with the middle of the fining pad. Now, make one pass across the glass as a finer test. Then inspect the fining. You should see a solid center, and you should be able to see wispy single lines on the edges. Make sure that the finer is not adjusted too heavily. If it is too heavy, a hard edge will be made and will cause distortion. After noting the results of the first pass, make any adjustments with the adjustment screw in increments of full turns. If it is heavy, back it out 1 full turn. If it is light, turn it down 1 full turn. Fine the scratch until the scratch just becomes invisible. This means every 3 or 4 passes, you will need to move the finer off the scratch, wipe down the glass, wait for the frosting to dry, and inspect it. If you need to use the finer less than 5 passes, you probably could have used just the polisher. Fining the scratch somewhere between 7 and 11 passes is normal. Once more than 11 passes have been made, you will see noticeable distortion in the finished project. How much fining is required depends on the depth of the scratch. This is plate glass. Plate glass is the most common type of glass. It is used in buildings and house windows. Plate glass is softer than laminated glass or tempered glass. Damage includes tree branch scuffs, glass-on-glass scuffs, and graffiti. Most plate glass is flat and very easy to work on. Laminated glass responds to polishing and fining in the same way plate glass does. However, the lamination process creates a harder surface on the glass. When you fine laminated glass, you must completely remove the harder glass surface to get to the softer glass underneath. When operating the finer, make at least 5 to 7 passes before you attempt to polish out the fining marks. This is tempered glass. It is the side light of an automobile. While the glass surface is up to 10 times harder than plate glass, the autostock system will easily remove scratches. You may find that you will need to fine and polish for longer periods of time. It may be necessary to do more frequent pad deglazings. The curved glass found on automobile windshields is laminated glass. Automotive sidelights and backlights are tempered glass. Some curves will be too sharp for the autostock system to operate. However, moderate curves can be worked. The key to working on most curved glass is operator experience. Later in the program, there will be specific recommendations for working on curved glass. Mirrored glass may be damaged by diamond rings, rivets on jeans, or graffiti. Distortion is usually not a problem with mirrored glass. It is usually very minor in comparison to the distortion on other types of glass. When you finish using the equipment, wipe the machine with a damp cloth. Make sure all the accumulated slurry has been removed. Next, inspect the machine, starting at the bottom with the pad. Inspect the pad's grooves and shape. Inspect the shroud seal. Make sure there are no nicks, cuts, or tears in the shroud seal. Also make sure the shroud feet are in good condition and have not come loose. Look at the water lubrication jets to make sure they have not been damaged. Then inspect the upper end of the machine, making sure that the input fitting is okay. Look at the extended input fitting and the O-ring on the extended input fitting. Take out the input fitting and inspect it for any grooves or wear patterns. Look at the switch to make sure it is not damaged and check the power cord. Do these inspections every time the machine is used. Maintenance schedule should be determined by how often the machine is used. Running time is not the determining factor in creating a maintenance schedule. The number of operations is. There is little difference in wear and tear on the machines if they are turned on for 2 hours or 2 minutes. If you use the polisher at least once a day, do a complete tear-down maintenance routine on a weekly basis. If you use the machine 3 or 4 times a week, then do the tear-down once every 10 days. If you use it twice a week, do the tear-down on a monthly basis. If you use the polisher 1 time a week or less, do this tear-down every 6 to 8 weeks. The finer maintenance schedule is also dependent on how often the machine is used. A normal finer maintenance interval is once every 2 to 4 times the polisher is maintained. If you encounter vacuum problems, consider doing the maintenance routine more often. One of the keys to keeping the machines running well is a thorough maintenance program. Now we will show you a maintenance teardown for the polisher. It can be separated into 2 segments, the lower end and the upper end. Lower end maintenance will revolve around the shroud and the quill shaft seal. The top end maintenance will revolve around the drive belt and extended input fittings. In the upper end, we begin by removing the input fitting. Pull in on the 2 tabs that hold the input tube in place. Lift it straight up and place it where it will not be damaged. Then remove the cover using a nut driver or straight slot screwdriver. The 4 slotted cap head screws need to be loosened but not removed. There are 2 on the back and 2 on the front. Remove the top motor housing. Lift it straight up until it clears the motor base. Use this side as a hinge and rotate it over. Inside, you can see the toothed drive belt and the two pulleys. Check the tension of the drive belt and adjust if necessary. To adjust the belt tension, first remove the switch. 2 screws are removed. The switch can then be moved, and you will see 4 hex head cap screws located on the top of the machine. Take your T-handle hex wrench and loosen, but do not remove these 4 screws. If you remove these screws, the motor will drop into the motor canister. The motor is mounted into grooves that allow it to move back and forth. That's how belt tension is adjusted. To tighten it, place your hand behind the motor canister and use your thumb to tension the belt. Make sure that the belt is tight. Most problems occur when the belt is not tightened enough. When the belt is at the proper tension, tighten the screws in an X pattern. Next, check if the belt is tracking correctly. Make sure that the small motor pulley is not too high or too low. Check this by placing a straight edge on the large drive shaft pulley. Swing it across to the other pulley. The straight edge should land directly on top of the motor pulley. If the pulley is too high, it may come off. If it is too low, the pulley will become prematurely worn. To adjust the motor's pulley, loosen the 2 set screws in the bottom of the pulley. Then, either tap it down or pull it up to the proper height. After adjusting the pulley, check the height again. Now we'll go through the steps required to replace the drive belt. First, remove the handle assembly using a 5/16 Allen wrench to remove the 2 cap head screws that keep the handle assembly in place. Then the handle assembly can be moved out of the way, and you can remove the drive belt going up and around the handle. To reinstall the handle, reverse the process. While you still have the cover and the switch off, take a clean rag and wipe off any grease or dried slurry. Now, reinstall the motor switch by lifting it up and over. Tighten the 2 hex head screws. When you replace the cover on the motor, be very careful to avoid catching any of the wires in the motor, the drive belt, or the switch top. The easiest way to do that is to hold the cover and use the flat end of the cover as a hinge to fold it over. Then check to see that the cover comes down without getting any wires caught. Continue to push it all the way down and tighten the 4 screws. The final area of maintenance on the top end is to clean the top oil light bushing on the drive shaft. Use a clean cotton swab to remove the residue on the bushing. It extends down about ½ inch. Clean around the inside of the bushing. The first time you pull the cotton swab out, it will look quite dirty. Take a clean one and repeat this procedure 2 or 3 times. You will never get the cotton swab completely clean. One precautionary note: do not use solvent or cleaning fluid. Use only a clean, dry cotton swab. After finishing the top, begin work on the bottom. First, remove the quill shaft cover. Then take the Allen wrench and loosen the shroud collar lock. Move the shroud up to expose the black O-ring on the quill shaft and lubricate it with a water-based lubricant that is included in the maintenance kit. Then push the shroud firmly down using a twisting motion. Now remove the pad by placing a half-inch wrench on the jam nut under the chuck. The threads are reversed, so turn the pad clockwise to remove it. Inspect the bottom of the pad and the polishing chuck for any slurry that may remain. Next, remove the polishing chuck. Do this by holding a half-inch wrench on the jam nut and turning the chuck clockwise to remove it. Then, remove the shroud from the machine. Lift it up with a slight twisting motion. The collar clamp should come off with the shroud. Next, remove the small jam nut using a 3/8 inch and a half-inch open-end wrench. The 3/8 inch wrench goes onto the milled slots on the drive shaft, and the half-inch wrench goes on the jam nut. Once loosened, remove the jam nut by hand and inspect it. Notice the internal threads have been ground off on half the nut. The portion with the ground threads goes onto the shaft first. The next step is to remove the drive shaft seal. Remove it with a pair of pliers. Grab the snap clamp and lift up. The clamp may become separated from the seal. As soon as it clears the seal, release the pliers and take it and the drive shaft seal off the shaft. Next, remove, inspect, and lubricate the quill shaft seal. To remove the seal, there is a small metal spring that encircles the drive shaft. Remove it by placing a screwdriver in the margin and lifting up on the small round spring. If the spring is undamaged, it may be used again. Next, the inner seal will be removed. Place a screwdriver against the edge and gently work it around the seal. When the seal gets high enough, remove and inspect it. On the interior of the quill shaft, you will see the remains of some grease. Take a clean cotton swab and remove the gross amount of old grease. Now we are ready to reassemble. Start by applying a small fillet of grease between the two seals right next to the drive shaft seal. Then, reinstall the seal with the recessed end up. The other end is flat. Put it on and push it down all the way into the quill shaft. It should completely seat on the bottom. In the drive shaft seal, clean out the recess between the two molded O-rings with a cotton swab. Apply a small bead of grease between the O-rings and reinstall them with the molded O-ring side on the top. Push it all the way down. Then take the snap clamp and position it on the drive shaft. Grab the clamp with the pliers and slide it down to the bottom of the drive shaft seal. About 1/16 of an inch should remain between the bottom of the clamp and the bottom of the drive shaft. Once we have repositioned the drive shaft seal, install the jam nut. The end with the ground-off threads goes on first. Remember, these are left-handed threads. Tighten finger tight. Once the jam nut is in place, inspect the quill shaft O-ring for excess lubricant. A small amount is required for proper installation. However, excessive lubricant will cause the shroud to slip out of adjustment. Position the shroud and make sure that the shroud collar clamp is in place. Slide the shroud and collar clamp down over the quill shaft. Then take the polishing chuck and inspect it for any dried slurry on the internal threads. If there is any present, remove it with a toothbrush. Replace the polishing chuck onto the drive shaft, turning it into place. When the chuck reaches the bottom of the shaft, hold the jam nut with a half-inch wrench. Then tighten the jam nut into the polishing chuck. Once the polishing chuck is in place, reinstall the polishing pad. The pad has reverse threads. Tighten hand tight. Then slide the shroud into position. Position the vacuum release valve next to the motor canister. Place the adjustment gauge on top of the pad and adjust the shroud height. The lower end of the drive shaft has an oil light bushing that needs to be cleaned just like the upper half. Use the same method. Now, grease the lower and upper bushings. Take a clean cotton swab, place a little grease on it, and lubricate the lower and upper oil light bushings. Then take the input fitting and clean it with a towel. Wipe off all the grease. Inspect the ends with a fingernail to see if there are any edges. There should be no wear marks or patterns. Then dab grease along the length of the shaft. Transfer the grease to the entire shaft. To test how the input fitting is wearing on the drive shaft, take the polisher and place the input tube into the oil light bushing. When it is released, it should drop into the machine slowly. If it drops quickly, the shaft and oil light bushings are becoming worn and should be replaced. After testing the shaft, push the two tabs in and lock the input fitting into the machine. Maintenance on the finer is done in the same manner. One of the easiest and most effective ways to maintain the slurry buckets is to keep them clean. Whenever you change slurries, remove the bucket top and pump and set them aside. Put them in a sink and wash them off with a sprayer. Then clean out the inside of the bucket with a scrub brush. Make sure any residue of old slurry is removed. Clean using only water. Use no soaps or detergents. Then fill the bucket half full with hot water and set the pump back into the bucket. Let it run for about 5 minutes. This will remove any residue from inside the aspirator and in the plumbing. Then take the top off, remove the pump, and wash it down again. Make sure it is clean, then rinse out the bucket. 2 other things should be done for bucket maintenance. First, on the aspirator assembly, remove the pickup tube from the hose. Then check the vacuum pickup tube to see if it is tight. The tube is made out of nylon and the aspirator is made out of ABS. They heat up, expand, and contract at different rates. When it becomes loose, take a wrench and tighten it down. The second item is the intake screen on the pump. Occasionally take the screen off and clean the dried slurry or other foreign material from the screen. There are no user-maintainable parts in the pump or the impeller assembly. Replace the intake screen and the hose on the vacuum pickup tube. The bucket is now ready for either long-term storage or immediate use. The maintenance on the water lubrication tank revolves around the plunger, inspecting and replacing the seals if necessary. Begin by lifting the pump assembly out. Set the bucket aside. Remove the white ring and lift it out. Be gentle with the tabs so you don't break or bend them. Then take the plunger out. Look at the umbrella valve seal on the bottom. Test it by putting your hand on one end. If the plunger does not hold pressure, the seal is bad. To remove the seal, first grab the umbrella valve with a pair of pliers and pull it out. Do not use a screwdriver to pry the seal out because it may damage the plastic and create a leak. Put a new seal in place by pushing down firmly with a slight twisting motion to help it seat. The next seal to replace is the top perimeter seal. This can be pulled out with the pliers. The new one goes in by pushing it down and around the threads. Make sure it ends up below the threads. The last seal is the perimeter seal for the inside of the plunger. When this begins to wear, the flange will flatten. To replace it, slide it off the plunger and slide on the new one. When you reassemble the tank, put water-based lubricant on the seals. Do not use any petroleum-based lubricant because it will destroy the seals. Line the tabs up and push the plunger into place. Screw the retainer ring back on. The assembly can now be placed into the water lubrication container. The first step to take when troubleshooting is to determine if the bucket is working well. Crimp the hose tightly as it comes out of the bucket. Hold it for 1 minute. The vacuum reading should be above 24 inches of mercury and steady. This means that all the components in the bucket and the bucket itself are in good working order. If the gauge reads under 24 inches of mercury, then the problem is in the bucket. When the vacuum goes up to 24 inches of mercury and then goes down or is unsteady, it is an indication of a bad aspirator. replace the aspirator. By crimping the hose at the machine end, we can determine if the hoses are in good condition. If the vacuum gauge goes up to 24 inches of mercury and remains steady, then the bucket and hoses are good. If it did not go up to 24 inches of mercury, the hose is bad. A leak, cut, or tear. It must be replaced. If the problem is in the bucket, check the following connections. The hose connection in the vacuum bleed. The hose connection going to the vacuum valve. The vacuum valve fitting going to the vacuum gauge. The vacuum gauge going to the Y fitting. The Y fitting in the bucket going to the aspirator and the vacuum pickup tube. Another area to check for a vacuum leak is where the nylon connectors are threaded into the brass body of the vacuum gauge. The brass and nylon heat at different rates, and this fitting may become loose over time. Another item to check is the aspirator. It must be perfectly straight, both horizontally and vertically. Make sure that the vacuum pickup tube is tight, and it is perfectly perpendicular to the aspirator assembly. Make sure that the hose going to the vacuum pickup tube has been properly inserted. Another area to check is the intake screen of the bucket system. Remove it and look for slurry clogging. Sometimes, when you close the top of the bucket, the hoses become bent or twisted. Another problem you may encounter is the slurry being too low. When you mix up the slurry, make sure the water level is on line with the bottom of the handle reinforcements before adding the polishing or fining compound. Over time, the slurry may drop below the vacuum pickup tube. A thick slurry can also be a problem. When fresh, the slurry is the consistency of a light cream. If the bucket is run under hot conditions, or there is evaporation of the water, the slurry will thicken. When it thickens too much, the pump cannot handle it. Throw away the old slurry and remix a new batch. Do not add water to the old slurry to thin it down. Mix a new batch. If you have determined that the problem is not in the bucket and the glass is not curved, then the problem is probably in the polisher or finer. A worn or defective shroud seal can often be a problem. After 1 hour of polishing time, the shroud seal will become worn or saturated and will lose some of its flexibility. If it is ripped, chipped, or looks stiff, it should be replaced. Also, check the vacuum release valve and grommet. The valve is the white plastic, and the grommet is the black rubber fitting around the valve. The only way to inspect it is to pull out the valve and look at the inner part of the grommet. If it looks worn, replace it. Another item that may cause problems at the machine end are the black O-rings that are located on both the white vacuum fittings and the black input fittings. Check to make sure there are no nicks or tears. On the finer, both fittings are on the shroud. Another place to look for a vacuum problem is the O-ring located on the quill shaft, directly underneath the shroud collar clamp. Remove the shroud collar clamp to inspect the black O-ring. Also check the drive shaft seal. This is one of the last places to look because of the amount of work required to check the seal for a leak. The last place to check for a leak is the shroud itself. The shrouds are glued out of 4 pieces of plastic. If it is dropped or knocked, it's possible that the glue seams could be broken. If you suspect the shroud, carefully flex it to see if there is movement between the four pieces of plastic. If the glass is curved, then there are several things you can try to hold the vacuum. Try reducing the amperage, increasing the water flow to the jets, riding the clutch, flexing the shroud, extending the shroud seal, increasing the vacuum, or a combination of these methods. Before operating the machines, be sure you have thoroughly familiarized yourself with the manual. Pay special attention to the sections on operational safety. We hope these tapes have been helpful and you have many successful hours using the autostock scratch removal system.